All right, we're going to look at 5B. 5B, we're looking at graphing sine and cosine curves that have been transformed somehow. So we're combining transformations with our sine and cosine graphs. So I'm actually going to skip the front page because the only thing that's on the front is the sine graph. And so I'm going to skip that for now. Same thing with cosine graph over here. So we're actually going to start on the second page where it says equations of sine and cosine graphs. So this is where we start getting away from the basic curves. We're going to make them a little bit more complicated. We're going to be changing our amplitude and our periods, and eventually we're going to do vertical shifts and phase shifts as well. So at the top here, we have the sine and cosine curves. We have y equals a sine of kx. And then we also have the cosine version. For these, A represents a number, and then K also represents a number as well. And then K specifically is going to be greater than 0. When we have sine and cosine curves with numbers in the A and K spot, our amplitude is always going to be based on A. And we want to do absolute value of A. Our period, we know a basic period is 2 pi, but if we end up changing that to figure out what our new period is going to be 2 pi over whatever k ends up being. So the number in front of x would go in the denominator there. So we're going to look at example 1 together, and this could be something that you would see on a test. It would look like this, where I give you the equation, I give you a graph, and I also give you a table that you can use as well. So example 1 says find the amplitude and period of the function y equals 4 cosine of 3x and sketch the graph. So first thing is I want to make sure that this kind of matches our two equations at the top. I'm going to bring those back down. And it looks like it's in the correct order. There's no way that we can rearrange it. Eventually, there will be something that will be added or subtracted, which could move around a little bit. So I know looking at this that my A is this 4 here. So this is A. And then my K is that 3. So my amplitude would be the absolute value of A. So the absolute value of 4, which would still be 4. And so since we know what amplitude is now, I know and can kind of picture what the graph is going to look like. So my amplitude is 4. My period is 2 pi over k. And then I'm going to plug in that k value. You don't have to write this one if you don't want to. I just wanted to show you kind of where it came from. So my k was 3, so now it ends up being 2 pi over 3. This tells me that instead of it taking 2 pi, so this much time before it starts to repeat itself, it's only going to take this long, and so I'm actually squishing it horizontally, so it's going to appear more squished. So in this table, these are my original x coordinates. When we do a period change, if I'm squishing it horizontally, these x coordinates will also change. So because I'm changing my period, I'm dividing each of these by whatever my k is. And since my k is 3, I'm dividing all of these by 3. So I'm going to take this, I'm going to do 0, and then I'm dividing by k, and my k was 3. Well, 0 divided by 3 is 0. So my point that was at 0 is not moving at all. It'll still be at 0. Then I have pi over 2. So I take my pi over 2 and I want to divide by 3. Now, if I'm dividing by 3, that is the same as multiplying by the reciprocal. And the reciprocal of 3 is 1/3. So I'm going to write it like this because this is easier for me, and then I'll make a note in a different color pen so we can remember. So I'm going to say, dividing by 3 is is the same as multiplying by 1/3. So when I multiply these, I multiply straight across. Pi times 1 is pi, and then 2 times 3 is 6. And I'm going to put a box around those. And I'm going to keep going. So my next one's pi. I am dividing by 3 or multiplying by 1/3. Because this was not a fraction, I'm just going to divide by 3, and I get pi over 3. Then I have 3 pi over 2. That is a fraction, so I'm going to multiply by 1/3. I multiply my numerators, and I multiply my denominators, so I get 3 pi over 6. Now, I do notice that this can be simplified, so I'm going to do that because if you look on the x-axis here, 3 pi over 6 does not show up because I can divide both the 3 and the 6 by 3. When I do that, my fraction simplifies to pi over 2. And pi over 2 is labeled on the x-axis, which is going to help us out. So I do want to simplify it if I can. And then 2 pi, so I have 2 pi and I'm dividing by 3, and I get 2 pi over 3. Which makes sense because we got 2 pi over 3 up here. So now I'm going to actually start off by graphing my basic curve, and then I'm going to do the new one with the period change and the amplitude change. So I'm going to go back up to my equation. I noticed that this is a cosine equation, so I want to start by graphing a cosine curve. So on my coordinate plane, I need to include some values on my y-axis. And since my amplitude is 4, I am probably just going to go up to 4 or 5 for both positive and negative. I'm going to do 5. So for my original cosine curve, you do want to have this memorized. You start at 1, and then at pi over 2 we're at 0, at pi we're at -1, 3 pi over 2 we're back on the x-axis, and then 2 pi we're back at 1. So cosine ends up looking like a U. And this one looks a little bit shallower because of my scale on the y-axis. So this is my basic y equals cosine of x curve. So that's my original. So let's actually label it like that too. Original. And now I want to apply my period change and my amplitude. We could do it in 2 different steps, but I think we can do it all in one. So what this means is my coordinate that was at 0, so this one, is getting moved to 0. So this one's not moving at all for my phase shift, but my amplitude is 4. So instead of being at 1, I multiply that by 4. 1 times 4 is 4. So I'm actually going to do a different color. My point ends up being up here. For my second point, my point that was at pi over 2, which is this one, is getting shifted to pi over 6. So I'm just shifting it to pi over 6. The y value of that point is at 0 because it's on the x-axis. Sorry, my hand's in the way. I multiply that by my amplitude. 0 times 4 is 0, so that stays there. Okay. You'll notice while I'm doing this, I never moved my left hand because I like to keep track of where I'm at. So now I go down here. And what you could also do is like make little check marks, like we graphed those first 2. So now pi, the point at pi is down here. It is getting shifted to pi over 3. So I'm going to shift this point all the way to pi over 3. The y value of that point is at -1. So I multiply that by my amplitude. That would give me -4, so I put it down here at -4. I put a little check mark. Then I have 3 pi over 2. This one is getting shifted to pi over 2. And then because it was on the x-axis, I'm going to keep it on the x-axis because 0 times 4 is still 0. My last point is at 2 pi. 2 pi is all the way over here, and it is getting shifted to 2 pi over 3. So 2 pi over 3 would be right here, and then the y value is 1. I multiply that by my amplitude, which is 4. So at 2 pi over 3, I'm going to put a point at 4. So we took our, oh, my point here is a little off. Sorry about that. It should be to the right a little bit. I didn't realize. We took our graph, and what we did is we squished it to do a period change, and we changed the amplitude. So if I connect these dots, I still want to make it a curved line, so it's a U shape. Oops. And this is my new graph for y equals 4 cosine of 3x, which was the equation up here that we needed to graph.